this video is going to be on solving equations where we can use quadratic methods to solve them. So if we take a look at example 4, the highest exponent is a 4. So this is not a quadratic equation, but we're going to use similar methods for quadratics to solve this. First of all, if we think back to the beginning of this class, we learned how to factor, and to factor we need to set the equation equal to 0. And to use quadratic formula we would need the equation equal to 0. So I'm going to go ahead and subtract 36 to both sides, or negative 36. So I'm going to put a negative 36 on both sides. Okay, and so to factor, we have to see if there's a GCF. So there is no GCF. And then we have to think of what multiplies to negative 36. So it has to multiply to negative 36, and it has to add to negative 5. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. Since it has to add to a negative, we know the bigger number has to be negative. And because it has to multiply to a negative, this one has to be positive. And then we would see that 4 and negative 9 would work. So then we'd set up our problem like this. Now if we put an x here and an x here, when we multiply, we add the exponents, and that would only make 2. So that's why we need a 2 here and a 2 here, so that way when we multiply this and FOIL it, we would get the x to the 4th. And then we're going to go ahead and put in our positive 4 and our negative 9. And now we have a binomial. Because this is a plus and this is a square, we learned when we learned to factor that that can't be factored. That is not a difference of squares. That's a sum. So the x squared plus 4 can't be factored further. But this x squared minus 9 is a difference of squares. And because 3 times 3 is 9 and x times x is x squared, we can split this into x plus 3 and x minus 3 and factor that. Okay, then once everything is completely factored, then we set each factor equal to 0. So we have x squared plus 4 equal to 0, x plus 3 equal to 0, and x minus 3 equal to 0. And then we solve each of those equations. So if we subtract 4 to both sides, we'd get x squared equals negative 4. And then square root both sides, because we learned in previous lessons in this chapter that 2 would go into 2 once, so this would go away. Whenever we put a radical into a problem, we do need to also include the plus or minus. And then the square root of negative 4, this would not be a real number, but because our directions say, and it is implied in this class, that we want to always, if we have a negative in the radical, instead of saying not a real number, we are going to also include the complex numbers. So it tells us here in the directions we're also including complex answers. So that is why we're going to split this up into square root of 4 times square root of negative 1, which is 2i. Okay, so now we have x equals 2i, x equals negative 2i, and then we continue to solve these equations here. And we would get negative 3 and positive 3. So we would get 4 solutions here. 2 of them are complex solutions, and 2 of them are real solutions. But we get a total of 4, and notice that the highest exponent's 4. So if you recall when we first learned how to solve equations that had exponents, when we did chapter 6, the highest exponent, that's called the degree, tells you the maximum number of solutions. So if the highest exponent's 5, you can get up to 5 solutions. So if the exponent's 4, you can have 4 answers, 3 answers, 2 answers, or 1 answer. Okay, so we solve this using factoring, but that is not what our lesson is. Our lesson is, because we already knew how to do this. So yes, that is our lesson, but we want to use quadratic methods. So that means a method that would only work for a quadratic. And so now I'm going to redo this problem, but this time we're going to use that quadratic formula we learned about in 9.2. So we're going to resolve this problem. And we're going to use the quadratic formula. So when we use the quadratic formula, it has to equal 0. And then the number in front of the highest exponent, that's going to be a. The number in front of the second term, that's b. And then the constant is c. Now the quadratic formula is for when it's x equals. So if the problem looked like this, this would be a quadratic equation. But because this problem here is not squared, it's like this. So to get it to 4, we'd have to square that. So x squared squared, that's how you would get x to the 4th. And if we square this x here, that's how you would get negative 5x squared. So that's how mathematicians figured out that if I still want to use the quadratic formula for things that aren't quadratic, so it's not called the quadratic formula if it's not the highest exponent's 4, we're going to tweak it by putting a 2 there, because x squared squared would get us the x to the 4th. So if we square the solution, or the x value there, then it would work out. So let's see if we get the same answers that we just got here, if this works. The only thing different we have to do is include that into our formula. So this is not called the quadratic formula, but we're going to use something very similar here to the quadratic formula. So it's x squared equals negative b plus or minus b squared minus 4ac all divided by 2a. So then we have the opposite of negative 5, that would make plus. So we would have 5 plus or minus the square root, negative 5 squared is 25, and then a negative times a negative is a positive. So if we put this in our calculator, negative 4 times 1 times negative 36, that's positive 144. So again, the only thing different is this 2 right here. So then 25 plus 144 is 169. And the square root of 169 is 13. And now to get our final answer, or to keep simplifying this, I should say, we would get x squared equals, and we'd have 5 plus 13 over 2, and then we'd have 5 minus 13 over 2. And then we keep going here. 5 plus 13 is 18. 18 divided by 2 is 9. And then over here, 5 minus 13 is negative 8 divided by 2 is negative 4. Now, if we stop there and we say our answer is negative 4 and 9, that is not what we got here. We got 4 answers. That's because we're not done. We want to solve for x. So now to solve this, we would square root both sides, giving us 2 answers here. Whenever we put that symbol in, we need a plus or minus. This would go away, and we would get plus or minus 3. And then here, when we square root both sides, we would get square root of 4 times square root of negative 1, right? And then we would substitute I in here. Square root of 4 is 2. So we would get plus or minus, because we always put a plus or minus when we put a radical in, and then 2i. We learned that last chapter. So if we look here, we get the same solutions. We get positive 2i, negative 2i, 3, and negative 3. So again, we can still use the quadratic when the exponent's a 4. all we have to do is add the square there, because if we do 2 times 2 here, we would get that 4 there. Okay, so we're essentially letting x be x squared. That's our substitution.